Good evening. My name is Keerthana V. I am studying in 4th SEM A section, ISC department, GM University. Today I am here to present a Automata theory and compiler design assignment. The main objective of this assignment is to implement a simple lexical analyzer and parser for a MiniATC language. And in this project, the lexical analyzer identifies tokens such as identifiers, numbers, operators, and delimiters, while the parser checks whether the given program follows proper grammar rules or not. So, let me screen share the assignment I have written. Assignment. Let's look into it deeper. So, brief theory explanation of automata theory is an important concept in compiler design. A lexical analyzer breaks the input program into smaller units called tokens. Smaller. So, automata theory is an important concept in compiler design. A lexical analyzer breaks the input program into smaller units called tokens. Then the parser verifies whether the syntax of the program is correct using context-free grammar or CFG. So we can briefly mention keywords like begin, end, int, or print. So identifiers are variable names, numbers means integer values, and operators we have the symbols of addition, subtraction, multiplication, division, or equals to. Delimiters are the things which we use while drawing and representing a thing, semicolon and brackets. And so here is the written content related to it. And now I'm going to show you the DFA diagram which we depicted to show our assignment topic. And this is the transition table. These are the final states. Like we mentioned, final states in double circle. Q1 is the identifier and keyword. Q2 is the number. Q3 is the operator. Here we have written lexical analyzer explanation. And this is the lexical analyzer code. And this is our parser code. Here I have also written about sample input and output. We have tested when we ran the code, and these are the test cases we have received. And now I will demonstrate the execution of the lexical analyzer program. So let me switch to that tab. So here we have the lexical analyzer code. Let's run it. While it runs, is keyword checks reserved words, and is identifier validates variable names, is number checks numeric values, and the main function reads tokens and classifies them. So let's try a sample input. Let's take begin int x, then x is equals to 10. So now when we ran it, we got output of enter tokens. Let's give these as a test cases. Let's enter. Now we have got the output. Then let's run parser code. Let's run it. Then we got an output of enter expression. Now let's try both valid cases and invalid cases. So let's give valid inputs first. These are the valid inputs. So we'll get a output like valid expression and code execution successful. Now let's give invalid inputs. So these are the invalid outputs I have given, and we got output of invalid expression. In this way, we have tried both valid and invalid inputs, and we have got respective output like valid expression and invalid expression. This parser's main goal is to give us or says us that whether the expression is valid or invalid, and it shows the whether syntax is correct or not. Parser detects syntax errors, and in conclusion, this assignment helped us understand the working of lexical analysis, tokenization, DFA, parsing techniques, and context-free grammar used in compiler design. Thank you.